everyone. We are now getting into our lesson for synthesis reactions. We just had a little bit of an introduction and you saw some application of synthesis reactions and some demonstrations. So here's where we want to take a look at what we've learned previously in grade 10 and kind of build upon our learning. So, in synthesis reactions, if you are able to download this lesson sheet, that would be fantastic. If you're not able to, that's okay too. You just want to write everything out into your 3-ring notebook. So, as indicated previously, a synthesis reaction involves the making of one product. And in grade 10, you would have learned simple synthesis reactions where an element plus an element yields a compound. Sometimes it's a little bit more complex, as we saw previously. So, let's do some examples together. When we are looking at simple synthesis reactions, what we're going to want to do is also take a look at our periodic table to help us indicate states as well. If it's white, it's a solid. If it's blue, it's a liquid. And if it is yellow, it is a gas. So with our first one, we see that calcium is a solid because it's white and oxygen is a gas. And we're going to write down calcium as a solid plus oxygen. Now I'm going to write oxygen as O2. This is one of our Hofbrinkels, which means it's a diatomic molecule. Hofbrinkel is just an acronym that we use to help us remember the elements that when they are by themselves, we must double them up, whether it's H2, O2, F2, Br2, I2, N2, or Cl2. So oxygen is a gas, as we saw, and that will yield, we put an arrow, not an equal sign, calcium oxide. Now the formula for calcium oxide, I look up the valence option for calcium, it's a 2, and oxygen is a -2. When we crisscross, those subscripts will reduce and you just get CaO. Whenever a solid and a gas come together, we will make a solid. When I take a look at my balancing, 1 calcium, 2 oxygen, 1 oxygen. So I must put a 2 out front here, and then I must put a 2 here. Let's take a look at some of our special case scenarios that we saw. Whenever we have a metal oxide in water, we know that it will yield something that is basic in nature. So this often contains hydroxide in its formula. So in this case, when you take a metal oxide and it gets added to water, it will form an aqueous base. The metal in this case happens to be potassium. And when I look up hydroxide on my polyatomic sheet, it has the formula OH. When I look at the valence options for this polyatomic group, it is a -1. When you crisscross, I technically can drop those brackets and you just get KOH. Okay, so if I was to just rewrite that without showing the charges, we notice that when the solid goes into the liquid, it becomes aqueous. So it becomes a solution. Let's take a look at our balancing. We have 2 potassium, so I will put a 2 out front here. You have 2 hydrogen, there's my 2 hydrogen, and 1, 2, there's my 2 oxygen, and I have 2 oxygen. So that is balanced. When you have a non-metal oxides tend to be gases, whereas metal oxides in their standard state tend to be solids. Water is always going to be a liquid. Whenever you add a non-metal oxide to water, you will produce something that is acidic. And in this case, we need to know that carbon dioxide plus water will yield carbonic acid. Now, carbonic acid has the formula H2CO3. So this is one where we get into our acid base unit. I'm going to have you memorize these acids. Now, how I kind of cheat and remember this, there's 2 H's, there's 1 carbon, there's 3 oxygens in total, add those up, and that's how I remember the formula for that. This happens to be nicely balanced. Acids are always aqueous, when you have this scenario. All right, a metal oxide, okay, and carbon dioxide yield something that is a metal carbonate. So in this case, the metal oxide, again, they tend to be solids. Carbon dioxide we know is a gas. When a solid and a gas come together, it will yield something that's a solid. So in this case, the metal is sodium, and carbonate, when I look on my polyatomic sheet, has the formula CO3 and a charge of -2. Sodium is a +1. When you crisscross, the 2 comes down here, and technically we can drop the brackets. This happens to be a solid. When I look at my balancing, 2 sodium, 1 carbon, 3 oxygens, everything is nice 1 to 1 to 1 ratio. So let's do a little bit more practice, and then you can check the rest to make sure that you are on track. So when aluminum and bromine come together, I'm going to go take a look at that periodic table to look at the state of both. Here's aluminum, it's a solid, and bromine happens to be a liquid. Aluminum, solid, plus bromine. Now, bromine is one of my Hofbrinkels. So that means that when it's by itself, I need to write it as Br2. Now, often I italicize my L, so I make it like a handwritten L so that you don't confuse it with the number 1. Okay? Now, what type of compound do I have? This is just a simple synthesis reaction, meaning an element coming together with another element. So what you do is you put those two elements together, and you're not going to write AlBr2 and just rewrite what you've got. You've got to go back to the original valence options. So aluminum is a +3 from our periodic table. Bromine is a -1. So this goes back to our ionic nomenclature. When you crisscross, the 3 comes down here. Now, when we go to balance, we need to think of a number for bromine that both 2 and 3 can divide into evenly. So I think of 6. So I'm going to put a 3 in front here, a 2 in front here, and that means I have 2 aluminum. When a solid and a liquid come together, it's going to yield solid aluminum bromide. Okay, now aluminum plus bromine, we have to complete the word equation here. Aluminum bromide. Okay, only when it combines with water would it become aqueous. Okay, now let's do another couple. Copper is a solid. Sulfur is a solid. What do I pick for copper? Now, when I am not given the valence option, what we do is we pick the more common valence option. I'm going to go back to our other periodic table that I have linked in our student resource section, and I noticed that copper can be a 2 or a 1. The 2 is the more common valence option. So in this case, we're going to pick Cu +2. Sulfur is a -2. Crisscross, and you just get CUS. Okay. Now at this point, you shouldn't really be needing to write those charges above. I just wanted to show you how to do that again. And a solid plus a solid coming together will yield a solid. Okay. And often there's got to be some sort of initiation here, like a catalyst or some sort of heat that's been added in order to get those two combine. Okay. So this here, we would call this copper 2 sulfide. Okay, let's continue on. Everything is nicely balanced there. Let's take a look at this example here, calcium oxide. This is one of our special case scenarios. So calcium oxide, calcium has a +2, oxygen has a -2. When I crisscross, I just get CaO. Most metal oxides are solids at room temperature. So we add this to water, and I have to ask myself, is this oxide a metal oxide or a non-metal oxide? And then I have to go back to my rules. So my rules in this case tell me that a metal oxide plus water yields a metal hydroxide. So in this case, I'm going to take the metal and I'm going to link it up with hydroxide. And I always put the polyatomic ion in brackets to begin with. Calcium is a +2, hydroxide is a -1. You crisscross and the 2 comes out. Now in this case, this is going into water, so you get an aqueous compound. We're going to call this calcium hydroxide. We don't use a Roman numeral because calcium only has one valence option. So calcium hydroxide. Okay, number 4, hydrogen. This is one of our Hofbrinkels, is going to be a gas when I take a look at the state. Chlorine is also a gas. It's also a Hofbrinkel. Makes sense. A gas and a gas will create another gas. Now, what is that going to be? Well, we're going to put down H. We're going to put Cl. We look at their valence options. So we're not going to write H2Cl2. Nope, we have to go back to when they're in a compound, what are their valences? We crisscross. And this is just hydrogen chloride. I do need to balance this. And I do think I forgot to check that my above one was balanced, but I think it is. 1 calcium, 2 hydrogens, 2 hydrogens, 2 oxygens, 2 oxygens. Perfect. So let's just complete our word equation here. This is just called hydrogen chloride. Okay, let's take a look at one down below here, just so you know what I am looking for. So in these cases from 9 to 14, you do not have to write the word equation and the balanced chemical equation, just complete the balanced chemical equation. So in question number 10, I see that I have a metal oxide in carbon dioxide. That is one of my special case scenarios. Metal oxides with carbon dioxide yield a metal carbonate. So I take the metal, which happens to be barium, and I'm going to hook it up with carbonate. So that is the polyatomic ion carbonate. What I do is I look at the valence options for barium, I look at the valence option for carbonate, crisscross, and technically I drop the brackets there, okay? Now metal oxides are solids. Carbon dioxide is a gas. When a solid and a gas come together, you make a solid. It's kind of like the solid always trumps the other states, except for when it's with water, okay? So with water, it becomes aqueous. Let's take a look at our last one, number 14. SO2 is sulfur dioxide. This is a non-metal oxide. Non-metal oxides tend to be gases at room temperature. When they go into water, we know that non-metal oxides form acids. So in this case, we know there are 2 scenarios that can happen, and this we learned with acid rain. Sulfur dioxide plus water will yield sulfurous acid. So what is the formula for sulfurous acid? Well, all I do, again, I cheat, and I see that there's H2, there's 1 S, and there's 3 oxygens. So that is called sulfurous acid. In the above situation, you are going to create sulfuric acid. Ic versus us, 2 different types of acids. So this is going to be H2SO4. And then we want to go back and balance those. So what I'd like you to do, complete the rest of these synthesis reactions, check your answers, and reach out if you have any questions.